Welcome to the Crazy Hat Chemist. So here we go once more again. Today we're doing Lewis dot structures. So let's get started. Bam! So the next Lewis dot structure is Lewis dot structure number 10. We're going to draw the Lewis dot structure for xenon difluoride. You might be asking yourself, xenon doesn't react with anything because it's a noble gas. Now, when I was a kid, way back a long time ago in the Stone Age, when I was learning chemistry, xenon was called an inert gas. And that means it didn't react with other things. In fact, all the noble gases were called inert gases. Well, we have since figured out that some of the noble gases do react with other elements. As you go down the group of noble gases, they do react. So, helium and neon don't have any compounds. Argon only has one. Krypton has a couple. And xenon has a few. So, xenon difluoride, this is almost like a binary, two nonmetals combined together. You see the di, that's for 2. So we need to write the formula for xenon difluoride, and that's right there, XeF2. Okay, now we're going to count up the number of valence electrons. There's 8 for xenon. Fluorine has 7, and there are 2 fluorines, so we're going to multiply that, then we're going to sum them up. And that gets us a total of 22 electrons. We're going to divide this by 2, and then that will give us 11 pairs. We're going to find the least electronegative element. That's the one that's furthest from fluorine, not fluorine. It has to be the xenon. The xenon is the least electronegative element that goes in the center. The other 2 elements here that I have are the 2 fluorines. Those 2 fluorines go outside that xenon just like that in an X marks the spot pattern. You could have drawn that in a variety of different ways. One on top, one on the bottom, one on top and one to the either right or left. That would have been fine. One on the bottom and either to the right or the left. That would have been fine too. The next thing we're going to do is we're going to place those 11 pairs of electrons appropriately according to the rules of the Lewis dot structure rules. So the first set of rules is to place a bonding pair of electrons between the central element and the outside elements. That is done just like that. Then the next rule is to place lone pairs, non-bonding pairs of electrons around the outside elements, and that is done just like that right there. Now, I have not used up all my 11 pairs of electrons, so then the next rule is to dump the remaining pairs of electrons as lone pairs or non-bonding pairs of electrons in the central element, and I have 3 more pairs left, and that is right there. Now, xenon is period 3 or greater. That's period 3, 4, 5, 6, or 7. So period 3 or greater. Yes, xenon can exceed the octet rule and be hypervalent. Okay, now I'm going to verify the octet rule with the fluorine, and fluorine must have an octet, and that looks like thus. Then the next thing we're going to do is we're going to tidy this picture up here and draw the bonding pairs of electrons as lines, the lone pairs of electrons on the outside of the fluorines as lone pairs still as dots, and the purple non-bonding pairs of electrons on the central fluorine, as the central xenon as also dots. So here we go to tidy that structure up. It looks nice and pretty. There are 3 sets of lone pairs of electrons on the xenon. There are 3 sets of lone pairs on the fluorine. The 2 fluorines have not exceeded the octet rule. They've maintained the octet rule. The xenon has exceeded the octet rule. It has 3 bonding pairs and 3 non-bonding pairs and 2 bonding pairs of electrons on that xenon. I am the Crazy Hat Chemist. Somewhere, somebody is having a birthday today, but it's not me at this moment in time. I hope you have a great day. Happy birthday to you and yours truly. Give me a thumbs up if you like that video and subscribe to my YouTube channel. Bye now.